In this section, we're going to be solving linear systems in 3 variables. What we're going to have here are linear equations of the form ax plus by plus cz is equal to d, where a, b, and c are all non-zero, meaning that they're all apparent in the equations. The following is an example of a system of 3 linear equations and 3 variables. We have equation 1 given as 3x plus 4y minus 8z equals negative 3. Equation 2 is x plus y plus 5z equals negative 12. In equation 3 we have as 4x minus 2y plus z equals 10. These really have nothing to do with the equations. It's just to help us keep them straight when we go to combine things. Typically, when we're solving these, we're going to have a solution that is an ordered triple. So just like in linear systems, we had an ordered pair solution where 2 lines cross at a point. Now we're going to have an ordered triple where we have these different functions crossing at a point. So I feel like the book does a pretty good job of illustrating this, so I put this in the video. We have 3 different planes, and again we have x, y, z variables that we're accounting for here, so it's going to be in 3 dimensions. We have 3 different plane opportunities here. So normally we're going to have 3 planes cross at exactly 1 point, and the book does a very good job of illustrating how 3 planes intersect at 1 point here. Basically, like you have 3 sheets of paper and they're going to cross at 1 point right in the middle. We also have the option of infinitely many solutions, and this is going to look a little bit different from time to time depending on how we solve our problems, but those are going to be some that are kind of interesting answers and maybe a little bit harder for us to get. And then the ones that are going to be very easy for us to get are down here at the bottom where it's no solution. Now, in linear systems, we only had one way to get no solution. It's parallel lines that don't intersect. But with these in 3 variables, we have a lot of different looks for no solution. But if you'll see here, none of these have all 3 planes crossing in either a point or a line. We have the red and the blue crossing, and then the red and the green in a different spot from where the blue and the green cross. And you guys can see these. Or we can have something that looks kind of similar to what we saw with linear functions and no solutions, where we have 3 parallel planes and they'll just never touch. But either way, keep in mind that when it's saying no solution, it's not saying that maybe 2 parts don't cross, but it's saying that all 3 parts don't cross at either a point or a line. So it's kind of wordy here, and the best way to look at this is to just go on and get into solving the problem. You guys can pause this and write it down. I'm not going to waste a bunch of time in the video reading through it. The one thing I want you guys to have your attention drawn to in this is just this sidebar here. So we have a false equation when 0 equals something, or basically whenever you obtain a false equation, you're going to put no solution right away. You don't have to continue working out the problem. But if you don't obtain a false equation, you have something such as 0 equals 0. The system has infinitely many solutions, and you can actually write it out as some kind of ordered triple. So looking at this equation, they've already numbered it off for us 1, 2, and 3. And so what my job is to do is to combine some equations together to get something to eliminate. And if you'll notice here, none of my coefficients are already the same. My 4, 2, 6, the x coefficients don't match up. 2, 3, 1, the y's don't match up. 3, 5, 4, the z's don't match up. So regardless of what variable I want to eliminate, I'm going to have to do some manipulating of my equations. What I'm going to do is I'm going to go ahead and choose to combine equation 1 and equation 2. So when I do that, I'm going to take a number, let's say I'm going to take 3 times equation 1 so that I can get my y's to cancel out, and I'm going to take 2 times equation 2 to get my y's to cancel out. So my new equation 1, I'm taking 3 through there, and I'm going to get 12x plus 6y plus 3z, whoops, not 3z, sorry, plus 9z, let's try that, equals 3 times 12, I get 36. And then I'm going to take 2 times equation 2, and I'm going to get 4x minus 6y, let's see, plus 10, sorry, plus 10z equals negative 14. I got a little ahead of myself there. Now I'm going to combine these two, and I'm going to give myself a new equation with 2 variables instead of 3. So now that I have these two ready to go, I'm going to add them together because my coefficients already are different signs. So I'm going to add them up because those two are going to eliminate for me nice and easy here. So I get 16x, the y's cancel, plus 19z is equal to 36 minus 14 is 22. So now I have a new equation 1 here, and I have an equation in 2 variables. Now what I'm going to do is I'm going to combine equation 1 and equation 3 so that I can get my y's to cancel once again. So I'm going to go over here. My equation 1 can stay exactly the same, so I don't have to multiply it by anything this time. 4x plus 2y plus 3z is equal to 12. My second equation, my equation 3, I need to multiply it by 2 so that my variable y will cancel. So I'm going to say 12x minus 2y plus 8z is equal to 2 times negative 3, I get negative 6. Now I can go ahead and combine these two equations and get a new equation 2, hopefully in 2 variables. So if I combine these, I get 16x, the y's cancel, 3 and 8z, I get plus 11z, whoops, plus 11z is equal to 6. Now if I look here at my equation 1 and my equation 2, when I go to put those together, I will have something cancel out. So let's go over to the side here. 16x plus 19z equals 22. So we'll say 16x plus 19z equals 22. And then my other equation, because my 16s are both positive, what I'm going to do with this one is distribute a negative. So I'm going to say negative 16x minus 11z is equal to negative 6. Now when I combine these, I can just add and they will cancel out. So the x's are going to cancel. 19 minus 11, I'm going to get 8z. 22 minus 6 is equal to 16. I can divide and finally find one of my variables, and I get z is equal to 2. Now, we have done a lot of work and we found one variable. So now kind of the hard part of this is done. Keep in mind, I found one variable. I don't want to go clear back to the beginning where I have 3 unknowns. I want to go back to the second step where I only have 2 unknowns. So now what I'm going to do is I'm going to take this 2 that I found and I'm going to plug it in for one of the z's in one of these 2 equations right here. So it doesn't matter which, I'll just plug it into the top one. We'll say, I'll pull it over here so we kind of don't get mixed up. We'll say 16x plus 19 times 2 equals 22. 16x plus 38 is equal to 22. 16x is equal to negative 16. We divide by 16 and we get x is equal to negative 1. So now I have 2 of my 3. Now I have to go clear back to the beginning. So I'm going to have to go up to one of my first equations, and it doesn't matter which, but I found x to be negative 1 and z to be 2. Let's go ahead and plug it into the top equation. 4x plus 2y plus 3z equals 12. So we're going to say 4 times negative 1 then we have plus 2y plus 3 times z, which is 2, is equal to, let's scroll up here just to make sure we've got this, is equal to 12. All right, we'll get this. Is equal to 12. Now all I need to do is solve for y. So I have negative 4 plus 2y plus 6 is equal to 12. 6 and negative 4, I have 2y plus 2 equals 12. I need to solve for my variable y, and I subtract 2. 2y equals 10, divide by 2. And after this long, lengthy problem, I finally found my answer. For y, it's 5. So now, you could have done this in any order, but your coordinate point answer should be -1, 5, 2 is your ordered triple answer. Again, a lot of stuff went on there, but you need to be able to show all that work and get to that end result. Make sure you run this video back, watch it over again if you need to see it. I'm going to go ahead and show you a couple more examples. Okay, so two scenarios here. One of them is pretty easy. If we go to combine equation 1 and equation 3, we can look at this and say, okay, let's go. Equation 1 is x plus y plus z is equal to 2. And then equation 3, I have 4x plus y minus 3z is equal to -6. And if I solve this one, I need to subtract all of them. So I'm going to distribute a negative sign through here. So that changes the signs like that. So x minus 4x is going to be -3x. The y's are going to cancel. Z plus 3z is going to be plus 4z is equal to 8. Now that one doesn't look any different, but look and see what happens when I combine equation 1 and equation 2. I have to multiply equation 1 by 5, so it's going to read 5x plus 5y plus 5z is equal to 10. And then my second equation is 5x plus 5y plus 5z is equal to 3. And you can pretty clearly tell here when I subtract, because these are all the same sign, if I want to get something to cancel, I have to subtract. This ends up with 0 equals 7. Once you see something like that, you're done. It doesn't matter what this first equation was. If we find something like this, we can't solve for that system, so we have to put no solution. That's your answer. You're done. Now, on the other hand, we have something a little different here with example 3. This one's a little bit more challenging. If we go through this, again, it doesn't matter the order in which you do it, but if we go through this and start to solve, let me get it zoomed in on here just a little bit and we'll move around, sorry. If I go to combine these, let's say that I want to combine and get the z's to cancel, because it looks like I can do that pretty easily. So first equations I'm going to mess with are equation 1 and 2, and then I'm going to combine 1 and 3. Okay? Or let's do this. Let's do 2 and 3. So we've combined both of them with 2, and that's fine. So my new first equation, after I do this, is going to be, let's see, x minus y plus z equals -3. And then with equation 2, it's going to say x minus y minus z equals -3. If I add, I get 2x minus 2y, and my z's cancel, equals -6. My other equation, what I'm going to do is combine 2 and 3. So if I write down equation 2, it's going to read x minus y minus z is equal to -3, and then 3 is 5x minus 5y plus z is equal to -15. So we're going to go ahead and combine these. My new equation is going to read 6x minus 6y. The z's cancel, and 15 and 3 give me -18. Now, if I look at this, when I go to combine my new equation 1 with my new equation 2, here's what it looks like. I need to multiply my new equation 1 by 3, first of all. So it's going to read 6x minus 6y equals negative 18. And then my other equation is also going to read 6x minus 6y is equal to negative 18. So what I have happen are both of my variables cancel, and I get 0 is equal to 0. So now I know that I have infinitely many solutions. That means what I have to do is figure out what variable I can isolate to put in for so that I can make my other equations look like a variable in that. So what we're going to do is go back, now that I know that I have infinitely many solutions. One of my variables is just going to be 0. What I have found, though, is that I have x and y here. I got my z's to cancel. So my z value is going to be 0 in this. And then what I'm going to do is pick one of these equations up above and isolate the x or the y. So I'm going to take one of those, and I'm just going to isolate one of the variables. Let's say I isolate x. So I'm going to take this exact equation right here and isolate an x so that I can write this as an ordered triple, and it means that it's going to be a line. I have to have a linear expression, so I'm going to zero out one of my coordinates, x, y, or z. So we are going to go ahead and zero out z and then write an equation in terms of x and y. So now in this equation I have 6x minus 6y is equal to negative 18. I'm going to isolate a variable. Let's just isolate the x because it's already positive there. So I'm going to add 6y to both sides. Those aren't like terms, so I end up with 6x equals 6y minus 18. And if I divide everything by 6, I get x is equal to y minus 3. So now what I can do is, instead of writing my value for x, I can write y minus 3 and write this as a variable expression where my z is zeroed out, and it might not always be z, but one of your values is going to be zeroed out because you only need two variables for a linear expression. And remember back from that picture stuff before, that are infinitely many solutions is a line because there's infinitely many points on a line. So instead of writing my x coordinate, what I'm going to write is y minus 3. My y value is still going to be y, and my z value is going to be 0. So now I have anything of the form y minus 3 comma y comma 0 will be a solution of this system. So for instance, if my value of y is 4, that means anything where 4 and then 4 minus 3 is 1, and then my y or my z value is always 0, that would be a solution of my system. And the reason this is infinitely many solutions is because whatever y is, you're just going to say that number minus 3 is going to be this point, and z is always going to be 0. So you can come up with infinitely many points that make that a true statement, whereas in example 1, we found exactly one point where all those planes meet, and that was done. That was all your answer was. So again, I know this is a lot to take in, but that's kind of the gist of the section and how you find them. Make sure you watch this video over again. If you have questions, ask them in class. We're going to spend some time working together on these. Hopefully we can get through these and do a pretty good job of it. Thanks. Good job, guys.